laws of exponents. We start with this example which says simplify. So we are dealing with simplification. Simplify. So this is the expression that we are supposed to simplify. Minus 6 times 2 power n plus 1 divided by 2 to the power n plus 1 times 5. Okay. The first thing you have to observe the expression. Observe the expression, any pattern that may present itself in that expression. Notice any pattern. Is there any pattern or something that is being repeated, or is there any sequence in that expression? Let's say, for example, you see that we have 2 to the power n plus 1, and also it is appearing here 2 to the power n plus 1, and also it is appearing here. So, okay, if it is on the numerator wise, to simplify, we can apply factorization. We can say, okay, the first point, we see that 2n plus 1 is common. So if it is common, we apply what? Apply factorization. So we can now factorize 2 to the power n plus 1. Then we'll be left with 1 minus, inside the bracket we are left with 1 minus 6 times 2 to the power, 2 is already gone. Okay, 2 is already gone. We have already factorized it. So this is what is inside our bracket. Then all over 2 to the power n plus 1 times 5. Okay, that dot also represents a multiplication sign. Okay, this and this cancels out, and then we are left with negative 5 over 5. That will give us negative 1. Okay, that's the shortest way, but there is also another way. We can do it. We can start by simplifying each component by applying laws of exponents, other laws of exponents. Like, okay, for instance, let's say for this one, we apply, which is general law number 1, which is m times 8 power n is equals to a n plus m. Okay, now so is here also. So it will be 8 power m times 8 power n is equals to a m plus n. It's a plus n. So okay, so at the end, okay, this one also applies the same rule. So at the end, we can say we will have 2 to the power n times 2 to the power 1 minus 6 2 to the power n times 2 to the power 1 divided by 2 to the power n times 2 to the power 1 times 5. This is what we have. Okay, then when you are here, we see that still factorization is still applicable here. is still applicable. So we factor out 2 to the power n, then we are left with 2 to the power 1 minus 6 times 2 to the power 1. And then at the bottom, 2 to the power n times, I can say it's a 10, 2 times that one give us a 10. Yeah. Okay, or let us leave it like that, then we'll do it at once. So this cancels with that. It cancels with that. Then on top now, we can say now is 2 minus 12, that's negative 10, then divided by 10. That will give us also a what? A 1. A 1. So they say there are many ways of killing a cat. So that's it for our first example. Okay, let's look into example number 2. Let's look into example number 2. In example number 2, we have to simplify this sum a to the power 5 times b to the power 3 divided by a to the power negative 2 times b to the power 4. Then multiply by square root, and then there is a cube root inside the square root or under the square root. A to the power 18, b to the power 36. That's what we have. So the first thing is to observe. You must have eyes that see what is happening. Okay, then the second thing, you have now to simplify each component or each part in the expression if possible. Okay, if possible. Okay, here we have numbers of the same base dividing. Numbers of the same base dividing. So we can apply our rule number 2 because there's division there. Divided by n, which will be what? A to the power m minus n. Okay, that's for the first component for both a and b. Okay, that will work out. And then square root. For square roots can be written as what? Square root of a is equals to a to the power, is equals to 1. Okay, it's equals to a to the power half, and then cube root or nth root. Okay, let's say just say let me not put it that way. Okay, let me not put it that way, I create confusion. Okay, okay, let me use nth root of a is equals to a to the power 1 over n. It's a to the power 1 over n. Okay, so it also applies to the cube root. So the square root, there is always a 2 there. They don't put it there. They don't indicate it most of the time, or always they don't indicate it. So, but note that there is always a what? There is a 2 when it is a square root. Then a cube root, there will be that 3. A fourth root, there will be a 4. A fifth root, there will be a 5. So it goes on and on and on like that. Okay, so we can simplify this part. It will be a 5 minus, for that from the law, then minus negative that sign, this negative sign of the 2. Okay, then times b to the power 3 minus 4. Then okay, that's how we simplify that one. Then times, we open bracket for the square root and open another bracket for the cube root. 8 power 18 b to power 36 or to the power 1 over 3. And then close bracket to the power half. Okay. And then this is our simplification. Let us not forget our equal signs. Okay. Let's not forget our equal signs. Okay, this is okay. Now I want to separate this thing that I may be able to put equal signs. Okay, let me put borders like this. Yes. And then equal sign. Equal signs makes mathematics looks beautiful. So that's the makeup of not only beautiful, but it's a language. Okay, so we have 8 power 7 b to power negative 1 times, okay, here we apply, we have to apply this rule, a power m, then bracket power n is equals to a m times n. So the powers, they multiply. Whenever we have a situation like this, the powers, they what? They multiply. Most students confuse it with rule number 1. Please note the difference there. Note the difference there. It's not the same as. It's not the same as. Let us write it down. It's not the same as a power m times a power n. It's not the same. You have to be able to differentiate this and this. Okay, so please take note of that. So the powers here, they do multiply, and what do we get? We'll get 8 power 18 b power 36 or to the power 1 over 6. Okay, and for this again, we apply a b. Okay, forgive me for that. A times b to the power m, it will be a power b to the power m. It's a to the power m times b to the power m. So the power outside multiplies the exponent outside multiplies every exponent inside. It multiplies every exponent inside. So there is a to the power 1, b to the power 1. So that's why we say 1 times m, it will give us an m. 1 times m, it will be m again. Okay. So we have a power 7, b to the power negative 1 times a 18 times 1 over 6, that will give us a 3. Then 36 times 1 over 6, that will give us a 6. Okay, then we have a situations like this now, where we can apply this law. Numbers of the same base, when they are multiplying, we add the exponents. So a 8 power 7 and 8 power 3, they are multiplying, so it will be 7 plus 3, that will be to the power 10, times b to the power negative 1 plus 6, that will be b to the power 5. Then that's our answer. We are done with example 2. Okay, let's look at okay, we are done with example 2. So for this video, that's what we have. So our next video, it will be for solving for x. solving for x, that's what we are going to look at. So if you have any question where you do not understand or you want us to improve, you say somewhere we have to improve it to give you